Hey, today we're going to talk about the VLab Lives of Stars. I'm assuming you were in class and you just need to go over this again, but if not, this is good because you're able to hear me talk about it. So, if you weren't in class, make sure you take a little bit of time. We've already talked about the nebular hypothesis, we've talked about our star life cycle, and we've talked about other star life cycles. Now, we're going to talk about how they put these together in a diagram. It's called an HR diagram. And this is a very small picture of an HR diagram, and they put the luminosity, which is how bright a star appears compared to our sun, on the vertical axis. And then they put the temperature in Kelvin on the horizontal axis. And the scientists that discovered it, their names were Hertzsprung and Russell. But just to keep it simple, they called it the H and R diagram. So that's where we're coming from here. And we're going to use a program called Star in the Box. And if you click on that, this is all on our Padlet links, or of course, you can find it through Schoology, and it will be called VLab Stars or VLab Lives of Stars. And so, if you click on um, the link that you get to in the lesson, you will see Star in the Box. Click Open Lid. You'll see this. If you go back to the paper that you have, or the e-copy, as the case may be, um, look at it. You can see the mass, the current age of the star, how to run or pause or restart the simulation, some more information. I'm going to go through all of it in the program in a second here. And you're going to collect information. In part one, you're going to collect the main sequence information. Okay, so I'm right here, part one, the main sequence information, and you're going to have the data table, this data table, that data table. And if you look at that data table, let me make that bigger for you. Okay, so this data table, and you can see the coordinates of the main sequence. That's what our first graph is going to be. And remember that these coordinates are the luminosity and the temperature. And then in class, I'm going to assign you a time for your group. So you should be working with someone. And then these are other pieces of information. So, like you had the main sequence, what happens for your main sequence star? Is it a smaller star? What's it going to do? What's the final stage? And how long did it take to leave the main sequence? Those are the information that you want to gather. But I would gather just the main sequence information first and then graph that information first. That way you have plenty of time to get that first graph done. So, first part of the first thing, I want to get the main sequence information. So here is starting at the smallest one, the mass of 0.2. And if I want to get the exact coordinates, I can just go to the dot. And so the luminosity, I come across, okay, stop. If I come across on the y-axis, the yes, the y-axis is 0.066. Whoops, sorry. Try again. And then the x-axis. Sorry, guys. Playing with a computer isn't always as easy as it looks. So I want the x-axis first, of course. So the Kelvin is 3,390, and the y-axis is 0.0085. Then I come down here and move it to 0.65. So now the mass is bigger. I'm going to come up to here. Now the Kelvin is 4,000. And yeah, sometimes it's going to be a little bit off. Yeah, if it's off by a few degrees, that's not the important part. The important part is you're getting the relative Kelvin and the relative luminosity. Luminosity is now 0.091. And then I'm recording that on my data table. And then I'm going to go to the next one, okay? So now this is about the size of our sun. Temperature is 6,000 Kelvin, and the luminosity is 0.92. So I'm going to get all that data. Once I have that data, I'm going to then put it on the graph. And again, we will go through this in class. If you miss it in class, grab me or grab someone that was there. Hopefully, your partner gathered the data the one day and you can work on the graphs the next day, something like that. And here's the data table. This data table is not identical to the data table in the star in the box. So you cannot just copy the picture. It's not going to work that way, okay? So we'll talk about that more in class. Make sure you ask questions if you need to. The second piece of information, so that's part one. Part two, stars change over time, right? We talked about that. Now we're going to see how they're going to change over time. You will get an assigned time for your group, and then you will come over here to the star in the box. And let's say your assigned time was 10 million years. Okay. So you will find about 10 million years. Sometimes you won't get exactly there. You have to click on the dotted line, by the way. If I click over here, it doesn't go anywhere. So if I click on the dotted line, I'm not going to get exactly 10 million years. So if I get close to 10 million years, yes, okay, that's close enough. I got 10 million. Oh, that's not even 10 million. That's more than, there's my 10 million. That's 100, that's a billions. Anyway, whatever number I give you, make sure you write the number down correctly. And you're going to get as close as you can, plus or minus, if you're plus or minus 43 of the, in the 100 billion year mark, it'll be okay. Because it's going to be a red giant. As you can see, this is a red giant for a very long time. And then it will suddenly become a white dwarf at some point. It falls from, it falls to white dwarf really fast. Okay, so then you'll gather that data for that specific time, whatever that time period is. That's why you'll want to write that down. Write your assigned time. Make sure you're checking for each star. So that star was the star size of our sun. You'll go through, do each star. Here's 10 times the mass of our star. What happens? If you're having trouble finding the time or clicking, like, see that one, it's going to take so we're talking about, yeah. So it's going to be a neutron star in that same length of time, 8,800 million years. The other one was a much bigger number. So anyway, it'll stay a neutron star. It doesn't. So ask questions again as you go through it. Gather all the data for that second time point, and then you'll make the second graph. If you run out of time, we're only going to focus on this for 1 or 2 days. I don't remember how long it took last year. We'll focus on this. Once we run out of time, at the very least, you should have the data table done. And once the data table is done, then you can answer these questions. But I would really like you to visually see the two graphs because I think it will help you a lot to answer those questions. So, plus it's more fun to do the graph, I think. So if you focus on getting the data and getting the graphs done, then part four becomes a lot easier to answer the questions. Make sure anytime that you're doing the hands-on activity like this, that you're asking each other, um, pulling me over if you're having trouble working this star in the box thing. Once you get the hang of it, it's really not that difficult. Uh, okay, and I will talk to you soon.